Dear chemists, today we are going to learn about nomenclature. But what is nomenclature? This is the scientific process of naming both living and non-living substances within a particular field. Under nomenclature, let us talk about chemical nomenclature. It is a set of rules to generate systematic names of chemical compounds. The nomenclature used most frequently worldwide is the one created and developed by the International Union of Pure and Applied Chemistry, the IUPAC. Different chemical nomenclature rules apply depending on the type of the substance. For example, KCl is potassium chloride since it is made up of elements potassium and chlorine. But note that while formal nomenclature rules apply to all substances, some of them have different alternative and common names that are used very frequently, e.g., H2O is commonly known as water instead of dihydrogen monoxide. Let's talk about nomenclature of organic compounds. IUPAC nomenclature for organic compounds is based on naming a molecule's largest chain of carbons connected by single bonds, whether it is a continuous chain or in a ring. All deviations, either multiple bonds or atoms other than carbon and hydrogen, are indicated by prefixes or suffixes according to the specific set of priorities. Naming of organic compounds. According to the terms provided by IUPAC naming system, 3 parts are required to be fulfilled when naming organic compounds, that is, the root word, the chemistry prefix, and the suffix. The root word indicates the number of carbon atoms present in the primary chain or the longest possible chain of carbon atoms. For example, hept in heptane refers to a 7 carbon atom chain length. The prefix is the part of the IUPAC name which appears before the root word. For example, cyclo is the prefix of the compound of cyclopropene, and it is used to differentiate between cyclic compound and acyclic compounds. Other prefixes we have fluoro, bromo, chloro, iodo, nitro, amino, hydroxyl, among others. The suffix refers to the main functional group and multiple bonds present within an organic compound. For example, OL in alcohol refers to the specific class of organic compound. The most basic suffixes used in organic chemistry are N, in, and yen. The suffix N is used when hydrocarbon chain is saturated, that is, having a single carbon-to-carbon bond. For example, ethane and propane. Suffixes in and yen are used to indicate the presence of double and triple bonds respectively. Therefore, the suffix represents the functional group of a compound. Some examples of functional groups are alcohol, aldehyde, carboxylic acid, carbonyl functional group, etc. General steps taken when naming organic compounds. Step 1. Find the longest continuous carbon chain. Determine the root name for this parent chain. In cyclic compounds, the ring is usually considered as the parent chain unless it is attached to a longer chain of carbons. Indicate a ring with the prefix cyclo before the root name. When there are 2 longest chains of equal length, use the chain with the greater number of substituents. Step 2. Number the chain in the direction such that the position number of the first substituent or multiple bond is the smaller number. If the first substituents from the either end have the same number, then number so that the second substituent has the smaller number. Step 3. Determine the name and the position of each substituent. A substituent on a nitrogen is written with an N instead of a number. If the carbon chain includes multiple bonds, replace N with in for an alkene and yen for an alkyne. Designate the position of the multiple bond with the number of the first carbon of the multiple bond. Step 4. Indicate the number of identical functional groups by prefixes di, tri, tetra, etc. Step 5. Place the position number and names of the substituent group in the alphabetical order before the root name. In the process of alphabetizing, ignore the prefixes like sec, di, tri, etc. but include iso and cycro. Always include a position number for each substituent. A note: for amines, a prefix amino and a suffix amine or amide are used, and a substituent on a nitrogen is denoted by N.